Okay, so this is our arc length arc sector question, but it's a mixture of properties of circle. So there's a semicircle of center O, right? So this one can tell is your diameter lah. So since this is diameter, right? So what we understand is this is your right angle triangle. Okay, so when I have my right angle triangle from here, so you will think of either Pythagoras theorem or Tokasu. So what do they want first? Okay, make sure your calculator is in radian mode, okay? So they want angle PST. So PST is this one. You must know how to recognize because the line that is opposite the right angle, right? This is your hypotenuse. So if this is your hypotenuse, that means according to this angle over here, this is opposite and this is adjacent. Okay, so opposite and adjacent. So let's say if I want to find, I let this angle PST be theta, okay? So if I do this, right, since it's opposite and adjacent, it should be tangent theta is opposite over adjacent. So then my theta tangent inverse like that. Okay, so you have it in five significant figure, radian mode, five significant figure, 0.39479. Then this is 0.395. So this one will be three significant figure. Alright, so the important thing is help me to put inside here. Okay, so this one here will be 0.39479. So the next question, right, is 1 mark only. So you expect one step or two step max, okay? So you want angle POT also. POT in radians. Where is POT though? POT is this one. Like that. Then like that. So angle POT, right, you can see it lies in the center leh. So center and circumference. So this one times 2. So from here, right, all you need to do for this one is your 0.39479 multiply by 2. So when you multiply by 2, 0.79498. This is 0.739, oh wait, 0.39479 times 2. 0.78958. Okay, so 3SF, because it's radian so like that. So they want you to write a reason, right? So the reason from here is angle at center equals to 2 times angle on circumference. Okay, so then after that from here, right? So this is one of the more exciting ones. So this one will be 0.7, wow, so thick this one. 0.78958. Okay, then the third one here, right? What do they want? They want the arc length of PQS. This is in radian mode, right? So if it's radian mode, right, what you understand is it will become arc length, your arc length formula is just in the formula sheet. So arc length is r theta. So if you can find the radius and you can find theta, then you'll be able to do it already. So what they want, arc length of PQS. Okay, so arc length PQS is where? So PQS is this one here, correct? So can you see if I close up, I get a sector, correct? So if I want to get a sector, what I want to do here is I want to find this angle here. So normally you will take 180 minus, right? But in this case, because it's radian mode, so radian mode you will take pi minus 0.78958. So pi minus this, so you get 2.35201. So this is your angle here, 2 point something. Okay, 2.3520. Then after that, right, I need the radius, right? How to find the radius? The radius is all here. I cannot find, right? And it's don't need to use sine rule, cosine rule, because too troublesome already. So what you remember is this is your Pythagoras theorem. So because of your Pythagoras theorem, okay, Pythagoras theorem, right? Your ST is the hypotenuse, remember? So ST square is 12 square plus 5 square. So when you do ST will be 13. That's the diameter. So because this is a diameter, that means my radius is 13 divided by 2. So 13 divided by 2 will be 6.5. Then after that, right, you just need your arc length. So your arc PQS, right? Formula ma, R ditter. Okay, then you press calculator. You can just give in 3SF, so 15.3 centimeter. So this question, important thing to understand is you must recognize this one, the pi minus something one. So then you know the angle, but you must know the formula first, right? Then once you have the radius, you just do your r theta. So always start by asking yourself, this one is formula or the long method one, the must angle over 360, that one. Last one is calculate the area of segment. Do you remember where's the segment? Segment will be either with or without the triangle, right? Segment of what though? Segment PQS. PQS, or maybe the shaded part. I believe they want the shaded part, right? So what we have here is, what you need to remember is area, correct? So area in your formula sheet will be half r square theta. Okay, so that's the formula, r theta or half r square theta. So formula first. Then after that, from here, I'm going to just do it here. So I want the shaded one, right? This is part C. Oh, this one is part C, I realize. This one should be part C. This is part D. Okay, so how do we actually do this? So you don't need to think so much. Don't need to worry about all these other parts here one. Oopsie. Okay, so what I want you to do is same thing. Use this, and then close it up like that. Okay, so you find the half r square theta, then after that minus away your triangle, which is half AB sine C. So I just do one step, okay? So half, your r is how much? Your r is 6.5. So r square theta is this one. So you don't have to always look at the whole figure. I don't even need to use the semicircle. So what is this answer? This is the sector. Okay, this is your sector area. Then next one is I want you to find triangle POS. This is half AB sine C, right? So half AB sine C. So this one will give you this, right? So if you just want the shaded segment, you will take the sector minus this one here. So when you minus away, then you get your answer in 3SF. Let me check the answer, yeah? Times 0.3 minus sine. Okay, so then at the end of the day, you should be able to get the answer, okay? Let's see, half. Yeah, so the sector that they want, just use your sector minus the triangle.